Okay, imagine for a second holding a tiny, completely transparent vial right in the palm of your hand. And inside that vial, suspended perfectly in a vacuum, floats a single microscopic glowing particle. I mean, it's barely even visible to the naked eye. But here's the crazy part. That tiny little speck is infinitely more valuable than all the gold, all the diamonds, and all the platinum on Earth combined. We're talking about a substance so incredibly rare and so unbelievably powerful that you could literally buy entire countries with just a handful of it. And no, this isn't some sci-fi concept or a prop from a superhero movie. This is absolutely real. We're talking about antimatter. So welcome to today's Explainer, where we're going to totally unpack the science, the inherent danger, and the absolute awe behind the single most expensive material known to mankind. So let's just dive right into this, because you might have seen this specific figure going incredibly viral across social media recently. $62.5 trillion. And just to be clear, that is not the price tag for a whole mountain of this material. That is the unimaginable, totally mind-boggling cost for just one single solitary gram of antimatter. To put that into perspective for you, that's more than the GDP of several major global economies combined, just for an amount that would barely fill up a sugar packet. It's an astronomical number, right? And it immediately begs the question, what on earth could possibly justify a price tag like that?
Well, let's get into section 1. What exactly is antimatter, the mirror to our world?
To really grasp why this stuff costs trillions, we have to look closely at the very fabric of reality itself. Now, you already know that the device you're watching this on, the chair you're sitting in, your own body, it's all made of normal matter. But modern physics has revealed this absolutely stunning secret. There is a hidden mirror world to our own. For every foundational building block of our universe, there exists an exact mirror image, which scientists call antiparticles. They look and act exactly like normal particles, but they carry the exact opposite electrical charge. And you can see that mirror concept perfectly illustrated right here. Over on the left, we've got our normal matter, the familiar electron with its negative charge, and the proton with its positive charge. But look over on the right. In the antimatter world, the electron's twin is called a positron, and it carries a positive charge. The proton's twin, that's the antiproton, carrying a negative charge. It's this perfect, beautiful, and as you'll see, highly volatile symmetry. Literally, every normal particle has this perfectly mirrored antimatter twin just waiting in the cosmic wings. And that volatility brings us perfectly to section 2, the power of annihilation, of volatile symmetry. See, these mirror particles, they absolutely cannot coexist. It's just not possible. When matter and antimatter come into physical contact, they undergo this process called annihilation. They don't just, mix together. They utterly and completely destroy each other. And they don't just vanish into nothingness either. They dramatically fulfill the most famous equation in the history of physics, Albert Einstein's E=mc². That equation basically tells us that mass and energy are interchangeable. Now, in normal chemical reactions, like if you're burning wood or firing off rocket fuel, only a tiny microscopic fraction of mass is actually turned into energy. But during matter-antimatter annihilation, that conversion is 100%. The mass is completely, instantly converted into an explosive, blinding burst of pure, unadulterated energy. So the absolutely crucial point here is the terrifying scale of power we're actually dealing with. If you took just that 1 gram of antimatter, the one that costs $62.5 trillion, and you allowed it to touch just 1 gram of normal matter, actually, scratch that, it wouldn't just blow up a laboratory. The resulting explosion would release the energy equivalent of a small nuclear bomb. We're talking massive shockwaves, blinding light, complete and catastrophic destruction, all from an amount of material so incredibly small it could comfortably rest right on the tip of your finger. That is the raw, terrifying power locked inside this stuff. Okay, moving on to section 3. Why so incredibly expensive? The cost of rarity. So naturally, if this substance is so incredibly powerful, you're probably wondering, why aren't we just mining it? Well, mostly because there isn't any just lying around. Scientists literally have to forge it themselves inside massive, unbelievably complex underground facilities, like the particle accelerators over at CERN. And the hurdles? They're huge. First off, production is agonizingly slow. Second, it requires just colossal amounts of electrical energy just to power the magnets and lasers needed to create a few microscopic particles. But honestly, the biggest hurdle of the whole shebang is containment. Remember annihilation? If your shiny, newly created antimatter touches the walls of a normal glass vial, or a metal container, or even a stray molecule of air, boom, game over, it's gone.
So to prevent this, scientists use unbelievably advanced tech to suspend these tiny particles inside incredibly strict magnetic fields, floating them in a perfect vacuum so they never touch the sides. Keeping those containment fields running 24/7 is an absolute engineering nightmare, and it drives the cost straight up to the heavens.
Now, before you start worrying about some supervillain stealing a high-tech briefcase full of antimatter to hold the world hostage, let me reassure you. The total amount of antimatter ever successfully created by humanity, globally, across all laboratories through all the decades of research, doesn't even come close to a single gram. We are literally talking about billionth of a gram. So currently the danger of some cataclysmic antimatter explosion here on Earth is virtually zero, simply because we just don't have enough of the stuff.
But let's pivot for a second. Section 4. Fueling future space travel. The ultimate fuel.
Let's look forward, out to the stars, and see how this builds our future capabilities. Look at today's rocket fuel. It is incredibly heavy and, frankly, terribly inefficient. Most of a rocket's weight is literally just the fuel it needs to lift the rest of the fuel off the ground. But antimatter energy is a total game changer. Because of that 100% mass-to-energy conversion we talked about, antimatter could provide thousands of times more energy than our current chemical rockets, using practically zero weight. We're talking about revolutionary propulsion systems here, systems that could slash the travel time to Mars from months down to just a matter of weeks, potentially opening up the outer solar system, and hey, maybe even neighboring stars to real human exploration. It is, without a doubt, the ultimate cosmic fuel.
Which brings us to our final point, Section 5. The great cosmic mystery, matter versus antimatter.
See, according to our absolute best understanding of the universe, exactly 13.8 billion years ago, the Big Bang happened. And in that explosive birth of reality, the math tells us that equal amounts of matter and antimatter should have been created. A perfect, clean 50-50 split. But think about it. If that were true, all of that matter and antimatter should have immediately collided, annihilated each other, and left behind a universe filled with absolutely nothing but cold, glowing light. No stars, no planets, definitely no us. Yet somehow, for some reason, the antimatter almost entirely vanished, leaving behind just enough regular matter to build galaxies, solar systems, and life itself.
Which leaves us with this profound, mind-bending cosmic cliffhanger. Why did matter survive while antimatter disappeared? Where exactly did the mirror universe go? Unlocking this secret is the true reason scientists are so relentlessly obsessed with this material. Yes, antimatter is the most expensive substance on Earth for sure, but its true value, it isn't measured in trillions of dollars. Its true value lies in human knowledge. By studying this unimaginably rare substance, we are literally decoding the very origins of our universe, and perhaps the very reason for our own existence. So the next time you look up at the night sky, ask yourself, what other incredible secrets are hiding in the dark, just waiting to be illuminated?